announcements. Don't forget that there are a whole bunch of events down the far hallway. Go visit the Hack Fortress, Hackers for Charity, go see ShmooCon Labs, go see other things besides just the talks, though this is going to be an awesome one. Since we're running behind, I'm not going to give away any swag, but go ahead and give a warm welcome to Sean Cassidy.
Okay, so I'm going to try to go through this quick because we have 10 minutes left and I want to leave time for questions. So I'm Sean, I'm the CTO of Praesidio. We are louder, please. Better? Good, all right. So I'm Sean, I'm the CTO of Praesidio. We're a cybersecurity management company for banks, but today I'm talking about phishing. So when we think of phishing, a lot of people think of something like this, like, crappy emails or something that really dumb, stupid users like to click through, and they, I guess, want to buy watches from email or something. And, IT people have always been, kind of annoyed about it, like, why do you click on these things? But really, phishing is actually an incredibly dangerous part of security. It is the primary source for attacks. So you don't have to take it from me, you can take it from the Gruck. And my favorite part of this quote is really that exploits aren't needed, they're not used, and they're not relevant. ODAs are just too valuable to burn, so instead you can just phish and get a better result with much, much less effort. So kind of like one way to think about it is this is what most phishing is, right? It hits you in the face with it. This is no big deal. Every IT person knows exactly what happened. Oh, this is a phishing attack. If you knew anything, this wouldn't have happened to you. I could just watch this forever. But this is really what I want the attack we're going to develop to be. This is Blade Runner. And so in Blade Runner, there are replicants, and there are, and the humans are trying to find who the replicants are, and there's this really intense test that they have to go through to find who are the replicants and who are the people. And that's what I want our phish to be. I want it to be so good that I want it to be tough for anyone to actually figure out it's a phish. So what would the ideal phishing attack be? Trained users are susceptible. So everybody always says, oh, we should train people to combat them, but an even better phishing attack is even if you knew the attack could happen, it could still happen to you. The attack should give access to machines, credentials, or good sensitive data. It should be hard to detect either during or after the fact. It should rely on a difficult to fix flaw because if you can just patch an ODA, it's no good after it's patched. So ideally, this phish would be kind of persistent and be widely applicable so that it affects a lot of users, or at least a lot of your target users. So let's just talk about kind of general anti-phishing techniques before we get into LastPass. So this is my conclusion slide, so I hope you all like my presentation. But really, this is what I want you to take away from my talk, that phishing is a software vulnerability, and it's really not the fault of dumb users, it's the fault of the software that is the reason why they're tricked. Users don't want to be phished. They would prefer not to be, and we need to make our software phishing resistant. And there's a few ways we can do that. But the main rule is if it's easy for an attacker to fake or confuse the user, the software itself is broken and the software should be fixed. Like email is kind of like a lost cause at this point, right? Like it's so hard to fix, but if we were redesigning an email replacement today, we would make sure it's hard for attackers to fake. If users are tricked, it's a fault of the designer, and really overall, good UX is a security measure. If you've ever done any user experience design, you know that anytime a user uses your application incorrectly is not the user's fault, it's your fault. Your application should have been better designed. As a corollary, software must be easy to use correctly. Okay, so some traditional anti-phishing techniques, training. Everybody always says training. We're going to see, I don't think that's enough. Trusted source verification. This is stuff like HTTPS extended validation type stuff. This is really Bank of America. This isn't some Bank of America with a K or something. All the email protections, SPF and everything, those are all just trusted source verifications. Binary signatures. There's going to be a talk about on Gatekeeper here. It's a binary signature type protection for OS X. Security images, if you ever logged into a bank and it's like, hey, choose the image so you know this is really us. It's just a trusted source verification type deal. Suspicious data warnings. This is just another simple thing. It's like, oh, hey, this email looks suspicious. And then even slightly more advanced is like phishing detection. So let's go into an example. Everybody knows Microsoft Word, and it has a few anti-phishing measures in it. So whenever you download something from the internet and open it up in Word, you see this protected view. And it happens no matter what the document contains. It's just like, hey, watch it. This document might be unsafe. It doesn't tell you why it's unsafe. It's just saying like, hey, just watch out in this kind of nondescript way. And you have to click enable editing and actually to enable you to interact with the document. So this is a totally fine one. And this is a malicious document. There's really no difference, and the user can't tell. And so if you click enable editing on this, you get this. Security warning, macros have been disabled. So, probably everybody in here knows Word can have malicious macros. And if you click enable content, your computer will be owned. But it looks really similar to the protected view thing. And you might say, enable content? I have Netflix. I love content. Just click content. But you could say, hey, users, don't click enable content always, right? So then, if you're a professional pen tester, you might do something like this: hey, click enable content to actually view this. So if you actually want to be a pen tester, this is actually a really easy way to do it. People really use this, and this really gets companies hacked. It is really, really effective. And you might not think about it. So I came up with some better names for enable content, because enable content is horrible. So like run malware would be really good. I think people would understand what that meant. Like, what's CryptoLocker? But really my favorite is YOLO, right? Just YOLO, who cares, whatever. And here's the OS X version, right? The OS X version is actually completely different, and it actually is sort of useful. It actually tells you macros are these harmful things, and you might want to not trust them. And the default is disable macros. This seems pretty reasonable, as opposed to enable content, where you're just YOLOing all over the place. So just summarize problems with Microsoft Word. It's got noisy messages. The warnings are unclear. What's a macro? It doesn't even explain it. Enable content sounds like a good thing. There's cross-platform inconsistency. But overall, the consequence of what the user is going to do is unclear. It is unclear that when you click enable content, your computer will be owned. Okay. So overall, anti-phishing design is about which pixels of the screen can be controlled by the attacker. If the attacker can control all the pixels, it doesn't matter, right? So anti-phishing is either reducing what pixels the attacker can control, walling them off and saying, look, these really aren't safe, warning them that these are untrustworthy somehow. But overall, you need to help the user make the right decision. You can't just say, oh, the user has to know what a macro is, or they have to be a programmer, they have to be an IT admin. Okay, so let's talk about our target. So we're going to target LastPass. LastPass is a browser extension. It is a password manager, and it holds passwords, credit cards, secure documents, whatever you want to put in it. It's very widely used. It's probably the most popular password manager. It has an API, which is going to be very important later. It's very easy to detect if someone's using LastPass, and if anyone's ever used it, it's kind of buggy. It's just slightly buggy around the edges, and that's going to be very useful for us, because if there's any inconsistency in our phishing attack, that's going to play into our favor, because it's like, oh, just LastPass has bugs, whatever. So let me just go through how LastPass works if you're unfamiliar with it. So it has a vault, and in the vault, all of your secrets are encrypted on your side, and they upload it to LastPass encrypted, so they don't have access to it. So you put in URLs of websites you're going to log into, names, usernames, passwords, all that stuff you'd expect. It can generate passwords for you, so you don't have to pick passwords on your own. It's very useful. You can click Use Password, and it saves it for you. So you can save your website. Then when you go to log in, it puts this little asterisk in the corner, and it's like, hey, you have one password on this website. So if you click that asterisk, it then fills in your password. So you only have, you don't have to remember all your passwords. Very easy. But this is the thing that caught my eye. I was using LastPass a few months ago, and it said my LastPass session appears to have expired. Please re-log in. And I had just been sent a link. It wasn't to ClickHole, which is a great website. Everybody should visit. And it was on a website I didn't trust, and I was like, what, this message shows up in my browser. Like, actually, ClickHole could have drawn this. I don't know if they didn't, and I looked into it, and it turns out they didn't. But that's when I got my first idea. Then when you click try again, it's going to log in. It's going to bring you to a login page. You can see this is actually in your browser. It has a Chrome extension URL. And then when you click login, it's going to communicate with LastPass servers, log you in. So I developed a plan for attacking LastPass. Okay, so step one, let's redirect the user to a benign-looking but malicious site, or a completely benign site like CNN.com, but it has a cross-site scripting vulnerability. So now this is important for phishing because most users have been trained, if you get an email that brings you to Bank of America, don't click it, right? Instead, go to Bank of America. But instead, if I send you a funny image of like a cat or something, I'm like, hey, David, check out this funny image. You have no problem. There's no danger in clicking that link. So I'm going to bring you to a website that looks completely normal and benign. Then, if you have LastPass installed, I'm going to put the banner up top and say, hey, your LastPass session appears to have expired. Please log in. That's my banner, not LastPass. It's going to look exactly the same. Then when they click our banner, I'll show them a fake login page that I control. And then if they need, if their account has two-factor enabled, then we will prompt them for their two-factor code, and then I'll download all their secrets. Okay, so now we have to do it. So step one, gathering the HTML. So I don't know if everybody knows about this, but there's an elite hacker technique called right-click inspect element. I'm a little nervous telling everybody about it, but it is awesome. So this is the real LastPass message, and I literally just right-click inspect element, and here's the HTML for it. It turns out it's an iframe. And so what I did was I just copied it into my own file. And there was a few CSS files, and I just copied them too. Here's like a CSS. You can actually just type in the exact thing, and you can right-click download the CSS. Very simple, very easy. This isn't hard. And so I got the notification HTML. For the login page, a slightly related hacker technique, I think this one was in Frac, right-click, view page source. Very easy, open it up, copy-paste, or you can save the page. It doesn't matter. All the HTML, all the images, actually all these are inline images, so it's really, really easy. And then we can then do our own. This is Firefox, though. I was showing you Chrome. This is Firefox, and Firefox pops up. This is on Windows 8. It pops up a Windows 8 window. This is a little harder because you can't obviously right-click on a Windows window and get the source, but it's still in the viewport. And because it's still in the viewport, we can do something with this. This is something we can do. We'll have to do a little more work later, but I think we can do it. Okay, so now we need to show the banner. We need to show our notification up top. Okay. First, we need to detect if LastPass is installed. When I started working on this, it used to be super easy. There used to be a JavaScript, there's a JavaScript variable called navigator.plugins, and if you gave it LastPass, it would tell you if LastPass was installed. They very wisely moved away from this because you shouldn't just broadcast all the plugins that you use. So we need to do something else. So I was looking at LastPass, and I saw the asterisk on a page, and I was like, how does that asterisk do? I opened up right-click inspect element, and I saw that it has a background image of, actually that asterisk is a background image. And I was like, what if I could detect the same thing? So I'll put a form on my page that looks like it's just a username and password field, and I'll see if LastPass actually detects it. So here, the function is LastPass installed. So I'll put, I'll get my username field. Very easy, very straightforward. This works after maybe 300 milliseconds because LastPass wants the page to settle before it draws all of the asterisks. But this is it. This is how you detect if LastPass installed. Very straightforward. And you can actually set the visibility of your form to hidden, and it will still draw it. So I don't have to show the form to the user even. So it doesn't have to even appear to the user. LastPass runs, is LastPass installed? Get the browser. If it's Chrome, insert the Chrome HTML. Otherwise, if it's Firefox, insert the HTML for Firefox. They're different, and you have to do them differently just because they don't really have cross-browser compatibility. So you have to do each individually, and that's it. Showing the banner is really easy. And here's my banner. I decided to use slightly different text. your account has been temporarily suspended. I thought that was a really good call to action. Like, oh man, my account's been suspended. Uh-oh, I better recover it. I really like that message. And it looks exactly the same as LastPass. Okay, but there's a major problem with this. If you ever use LastPass, you know that they put a big LastPass button on your bar, and it's red when you're logged in and yellow or gray if you're not logged in. So my whole attack kind of fell apart. I was like, oh, the user could literally just look at that icon and then tell if they were actually logged out or not. I was on LastPass's bug crowd page. By the way, bug crowd and bug bounty lists are a really good place to find vulnerabilities. And I'm not talking about like, oh, you'll go there and then search for vulnerabilities. The exclusions list is a really interesting place to find like really low severity vulnerabilities, because everything that they exclude is something that people report. And if they exclude it, they don't want to know about it because it's probably not fixed. So I was looking on their out of scope, and they have a logout cross-site request forgery exclusion. And I'm like, what? The only reason they have this on their exclusion list, so a logout cross-site request forgery, by the way, is a way you can log people out of a website or something without having access. You on your website, you want to log out of /dot, you put this link and you're automatically logged out of /dot. So LastPass has the same thing. So if I put on my website this, you're logged out of LastPass. That's all you have to do. It's a GET request. I don't even have to open up my thing. They're going to see a gray or yellow icon instead of a red one. So you have been logged out. This is real. Nothing is wrong. Everything looks good. Okay. Gobbledygook and some stuff, and we're going to have to display this HTML. The HTML is the easy part. But here's a problem, the protocol. So on Chrome, it has this Chrome extension. I can't spoof this. There's probably, somebody could maybe find a bug in this, but I couldn't. And so I needed a way to work around that. But there's this really huge random-looking string that's gonna help us out because the users aren't going to be paying super close attention. And my favorite part, though, is it looks like an unencrypted connection. If they had put a lock or some kind of info bubble there saying that this is an extension, it would have been totally done. So this is what I did. I just bought chromeextension.pw. It's pretty close. It's a PW domain, PW for passwords, right? Password manager. I figured it was pretty good. It was $3. So the URL, most of the URL hides, it hides it. It still has the same icon, and I actually surveyed a few people at my job, and I was like, look, this is a phishing attack, spot the phishing attack. And one of my coworkers said, how did you spoof the Chrome extension? I even looked at that. And like he even was looking for it, and he couldn't find it. And this is an expert computer user. So this was just a really nifty, low-cost solution. Okay, so there's another problem. I wonder if anyone can see it. So this is my page, and there's a pretty major problem with this. So LastPass has drawn an asterisk on the email field. It detected a form. So we're going to right-click Inspect Element, and what the first one is it just inserts a div, and then it literally absolutely positions it pixel by pixel to the exact place it needs to be. That's it. That's all it does. And we just need to remove that. So we need to remove the div. So it's added at runtime, and it's just in the DOM, so we can remove it. So the big question is, how do you detect when the DOM has changed? To this element of this type, call my function, and then so what I can do is I can actually add it to the body, and then in my function I will remove the div. So let's just look at it. Here's my mutation observer. It's going to have a function called the list of mutations that happened. So for every mutation, call this function. If it added nodes, then let's go through every single node that it added, and let's get that node. And if the node starts with __LP, actually in my code it's a little better, I had to condense it to fit on the slide, just remove it, and that's it. And listen on document.body for child elements. That's all this is. So now whenever LastPass tries to add the asterisk, we will remove it. Unfortunately, the master password actually uses a different technique. It goes back to the drawing the background image method. So we're going to use another mutation observer. However, this time we're going to listen on attributes, and we're going to reset the style whenever the style is changed to add the background image. However, there's a major problem with this code. The major problem with this code, I don't know if anybody has already seen the major problem with this code, is it causes an infinite loop. I'm saying, hey, whenever the style changes, change the style, and then that style changes the style, and that's and forever. So actually, this actually hard locks Firefox. It locks it up really, really good. Really, nobody cares about browser DOSes anymore, but I gave you, this is the tweet size version of the DOS if you want it. It's fun. It doesn't just lock up the tab, it locks everything up instantly. It's kind of fun, punk your friends with it. So, okay, here it is. Here's our login page. No asterisks, looks really good, exactly the same except for the .pw. Okay, the next step, we have to also get the two-factor authentication thing. It's going to be really straightforward. Here's my version. There's no difference. I'm just flipping back and forth. There's no difference, just the .pw domain. Okay, so the Firefox login screen. This is a little harder. It uses a Windows pop-up window, and on OS X it kind of slides out from the top, so it's actually cross-platform dependent. And on Linux it's kind of all over the place, but it's similar to Windows. So what we're going to have to do is we're going to have to do some hard work and actually figure out how to draw that thing on, on each platform. But luckily, HTML and CSS are really good, so this is what we need. We need HTML and CSS for dummies. It makes phishing easier. It turns out HTML and CSS are super powerful. At the worst case, you could put a canvas up and draw every single pixel exactly the way you wanted, but I didn't need to do that. It was very easy to just draw it. So here it is. Here's my version and LastPass's version. Which one's which? There are some differences. I kind of ran out of time, but they're very, very close. I asked some people at my job. They couldn't figure it out. If you can figure it out, you have sharp eyes. Left. Somebody said the left is the real one? No, left is the fake one. The right's the real one? Okay, well, I won't tell you. But anyway, yeah, there's a few differences. If I spent a little more time, this took me like just a few hours to cook up. If I spent a few more hours, I could make it exactly the same. Yeah, so the question was, is there a little shading on the right? Yeah, there's some minor shading differences. Also, my bottom arrow isn't quite the same. There's some text width differences, but it's pretty close. Here it is on OS X. Again, there's some slight differences, but it's pretty close. And I think if you were actually using it, you wouldn't be able to tell. I'm not going to display you two, obviously. I'm going to display you one. And you will have to then figure out from that minor shadow difference or something that this isn't the real one. That's not a good security policy. You would never actually say like, oh yeah, users, just measure the box shadow width, like, and then you'll know which is real and which is fake. So I'm also really interested, like, if you could just draw anything on a page, you can draw anything. So, sometimes the OS X pops up messages that are just like, oh, this is trying to unlock, or this software is installing, and I can draw those same messages. So I'm actually really curious what people can do with just like drawing the exact same message just on pages. Because if your browser viewport is 90% of your screen, 90% of your time, like that's just a huge attack vector because people can draw anything they want on it. Okay, step 4. We are going to actually make this a real attack and steal all of your data. Okay. So what will happen? Once the user hits login, it's going to send the credentials to our attacking server. Our server is going to call the LastPass mobile API only because that was the easy Python library I found. If two-factor is required, we're going to report that back to the user and they're going to get redirected to the two-factor screen. Otherwise, we're going to have the plain text secrets and report success. This all takes like a millisecond. It doesn't take a very long time. And when you log in, it actually gives you all of the stuff decrypted. So first, we're going to send the credentials. The victim presses login. This is actually just the username and password encoded in a base64. I'm going to decode that base64 into an email and password. And then we're going to use this LastPass API I found in Python, vault, open remote, email, password. And the vault is just, that has all of your secrets in it. I'll print them out for you during my demo. We need to catch exceptions. If two-factor is required, it just throws you an exception, and it's like, oh, you need Google Authenticator, so show the Google Authenticator one. It just tells you exactly which two-factor you need. I don't have to know, so I can show you the exact right one. Otherwise, we know it's an incorrect password, and then I can actually redirect you back to the malicious landing page with saying invalid password. So it actually does the exact same thing LastPass is doing, even if you type in the wrong password. So if you have two-factor authentication, I'm going to redirect you to this whole crazy thing. The only thing here is that I actually pass along the email and password to this, so I don't need to keep any state on the server. Makes the server really easy to deploy. It's just one Python script. Doesn't need to store anything like, oh, this person sent me this. Very easy. The victim then enters the two-factor code, and so then they're going to issue a GET. This is the two-factor code / the password. Very easy, straightforward. This is just something I cooked up. You could make a different API. It's very easy. Then we're going to try and maintain access. So Google two-factor codes are actually good for 30 seconds. You can reuse it. We could add our server as a trusted device. They have this special thing you can actually add as a trusted device. You can maintain access for 30 days. You could disable two-factor authentication because you actually have the two-factor code. You could download all their login history. You could recover deleted items. You could disable security policies. You could do whatever you needed to. Okay, let's see it. Okay, it's a little small. Maybe make this a little bigger. All right. So I have my Windows victim, and this is my Xubuntu attacking server, and we can see your account has been temporarily suspended. We click Recover Account, and the first thing I'm going to do is I'm going to type in an incorrect password. Click Login. It's going to redirect us to this, and then back here, invalid password. And this is actually using the real LastPass API right now. And then, so I will type my real password. And now I got redirected to my Google Authenticator, and I will actually go type in the real code. Hey, everybody, please don't steal my LastPass account, by the way. Authenticate. And then we'll get redirected back to this page with $Y, which means suppress the notification. Easy. But let's look over here on the Xubuntu. Can everybody read this? So we can see we got the username, password, example test. We got the two-factor code, and let me make this a little bigger. And here are all of the secrets. So we have the username, the password, the website. You can actually dump everything. It's all here. Yeah. So that is Chrome. And let me show you Firefox.
The browser icon didn't turn red. So users already lost the password, but they would get.
Yes. So actually, there's a slight thing after the demo. LastPass has fixed some of these problems. And so one of the things they've fixed is the log out cross-site request forgery. Good spot. Yeah, and sorry. The question was the LastPass icon did not turn red. That is true. I can't actually log you into that, so the user might be like, what's up, LastPass? Why didn't the icon turn red? But I've had LastPass do really funky things, so I actually think it's not crazy to suspect that the user would just then click it and be like, oh, I guess it didn't work. Let me try logging again. So let me just do the Firefox one. So the Firefox one looks a little different. Pops up. Here it is. It even drags. Oh, wow. So, watch this. I even did the Windows 8 little animation. Do you see how it pops up? CSS animations. Ooh, and then it goes away. Whoosh. Perfect. Yeah, so, okay. We got a lot more to talk about, so that was the demo. Okay, implications for what this means. Phishing LastPass is kind of like the worst case scenario. If you use LastPass shared folders, which is a new feature in the premium, or you could use enterprise, only one of your team members actually needs to be phished. So you might say, oh, I'm the smartest person here. I would never be phished, but are you going to be sure that everyone on your team is not going to be phished, or anyone you shared your passwords with aren't going to be phished? And you really lose everything. You lose all of your passwords instantly. As soon as you type that in, I have them already. Your credit cards, your secure documents, everything is gone. And the biggest thing is two-factor is of no help. It doesn't help you at all. Two-factor, which is, everyone's like, oh yeah, just use two-factor. Because you typed it into me, I can just use it. But we're going to talk a little bit more about two-factor later. So this is what I recommended to LastPass. Block logins from new IP addresses. If you're a really experienced LastPass user, you might say, they actually already do this. We're going to talk about that. Don't display notifications in the browser window. I think this is a really, really bad idea. Don't do it. So they actually have two styles of login. They actually have the full web page login, and they have the special pop-up style login. And they use, it seems like they use half and half. But if they just always use the pop-up style, I can't draw that because that's part of Chrome. I can't draw that. You can move to an HTTPS extended validation page. Some of their competitors use this. It seems to work okay. I'm not going to try and fake an extended validation one. You can implement a security image. That's okay. Really what I want them to do is implement cross-origin protection properly so that you actually can prevent cross-site request forgeries. And really just making the user experience less buggy is going to stop things like, the icon didn't turn back to red and stuff like that. So the response from LastPass, this is kind of a complicated, long story. So I contacted them in November. I was actually originally going to contact them earlier, but I'll talk about that in a minute. But due to some kind of communication snafu, they only got back to me in December. And immediately they kind of went dark. They said, thanks for the bug. See ya. And I'm like, okay, I'm going to be talking on this at ShmooCon. We should probably work on this. And I didn't hear much, which is very uncommon. LastPass has a very, very good reputation for responding to people. And then this week, I guess, ShmooCon was coming up. I got a lot of contact from them, and I got a lot of different messages, like, this is definitely a bug in LastPass. Thanks for fixing it. Submit it to BugCrowd. We'll pay you. And then their GM of product was like, this is not a vulnerability in LastPass. And then they were saying, well, we'll fix the logout CSRF. They actually did that, but we're not going to fix the notifications. The notifications are just part of LastPass. We're just not going to do it. And then they were like, well, it's really Chrome's issue. The Chrome extension protocol should be protected. I agree that is Chrome's issue, but there was a lot of different stuff here. And LastPass, I just want to say, I really like these guys. They're really honest, nice people, and they really do want to make their users secure. But this is really, I think, a trend in our industry. We don't take phishing very seriously. And I think that's what we're seeing here. One of the main responses from LastPass, though, was this whole attack shouldn't work. It should not work at all because of this. When you log in from a new IP address, LastPass is supposed to send you an email saying, hey, new IP address, do you want to confirm this? And I had never seen this. And they were like, your whole attack must not work because of this feature we have. And I'm like, oh, wow, maybe I'm just terrible, right? I mean, look, it literally says we require users on new computers and mobile devices. And then I kept reading the sentence, unless they have multi-factor authentication enabled. So this actually brings us to a really weird conclusion. I actually wrote a haiku about it. If you use LastPass, two-factor authentication makes you less secure. Don't disable two-factor authentication, but this is a really weird conclusion, right? And really, really surprising. Nobody that would enable two-factor authentication wants less security. That's literally backwards. So let's just talk about what they fixed so far. They fixed in Chrome the logout, the CSRF. Firefox is still vulnerable. Chrome now warns the user about leaking master passwords. So if you type in your master password, it pops up a message saying, hey, you just typed in your master password. And what won't change for now is they're still going to use in-view port notifications, and the login page is still vulnerable. We're still talking about this, but they're kind of resistant to changing it. They really want Chrome to fix it. And when I asked about Firefox, because I drew the same thing in Firefox, they were like, I don't know. The Chrome extension URL bar. So I tried out the new thing where you actually type in your master password, and it pops up a message, and it's like, hey, this site has the same password as your LastPass account. And then I was like, well, it looks like they're displaying the same thing in the browser, so let's use our Elite Hacker tool, right-click Inspect Element, and I'm like, oh, okay, it's still in the DOM. I can still detect this. So now I have a thing that if you type in your master password and then LastPass tells you about it, I instantly know. And I actually don't need to ask LastPass about it. So as soon as you type in your master password, I can add a tiny bit of JavaScript that then says, now I know your LastPass master password. Because they're drawing it in the DOM and attackers can control that, I can find it. So here I just popped up a thing. Here's your email and password. But I could have, instead of popping up the alert, sent it to my server. I could have tried logging in. I could have done whatever I wanted. And the best part is I can also suppress that message. I can say that little message I can suppress. I can't suppress the Chrome one. You can actually see it in the top right. I can't suppress that one, but I can suppress the one in the browser. So I just removed that, and this is why they have to get away. Using the Chrome-style notification, good. Using in-browser notifications, a lot less good. And this is really why I think LastPass's response is the way it is. They exclude phishing as part of their bug bounty program. I actually originally wasn't going to even submit it, but a friend of mine convinced me to. He's like, this is not normal phishing. And this is why I think I'm seeing this like really kind of complicated, not well understood response, just because this sort of thing, people aren't well trained. If you get a remote code execution, you know exactly what you need to do, you need to fix it. But phishing is a lot less clear. It's a lot less like, oh, well, is it dumb users? I don't care about dumb users, but like, it's not clear. So mitigations for users, just ignore notifications, just always interact with the icon and you'll be good. So there's some premium and enterprise mitigations. You can enable IP restrictions so that not everyone can log in. You can disable mobile login, which helps only against my attack. Somebody else could use the non-mobile API. Mine just happens to use that. Log all logins and login attempt failures. LastPass makes this very easy. Probably shouldn't disable two-factor authentication, even though that makes this. I definitely do not want to recommend that. So you can actually almost get around the IP restriction too. Since LastPass doesn't use cores and they accept text plain JSON via a post, which is the backwards compatibility thing to get around cross-origin things, you intercept the credentials, you issue an AJAX request, but you can't read the response because of cross-origin restrictions. But we're super safe because browsers have no bugs in cross-origin restrictions, except Firefox that had a bug in cross-origin restrictions. Right as I was making this, if I had known about this before Firefox had fixed it, I could have used this and actually gotten around the IP address restrictions so that it was actually your IP address requesting your LastPass credentials. If you use cores, that's just another bit of defense you can have. Lessons for software developers. Definitely design your software with phishing in mind. It is not your user's fault. You should be designing your software to itself be phishing resistant. You can add specific anti-phishing measures. Don't use the viewport. Anything you draw on the viewport, I can detect. So if it's anything security related, I can find out about it. I can enumerate all your different extensions, and I can interact with them. I can remove them. I can replace them with my own. Non-buggy user experiences are really important for software. And you also need to fix low-severity security bugs. I chained together a few different low-severity security bugs to make this work. Like a log-out cross-site request forger usually is no big deal. Who cares? You're logged out. But I used it as part of a bigger vulnerability. I'll chain them together, and I'll make it a high-severity vulnerability. Bug bounties are not going to just fix all of your worries automatically, and really use cross-origin restrictions and check content types. It's worthwhile. Lessons for users: keeping all your secrets in one place is dangerous. Making a phishing threat model is really interesting. So if you're like, okay, well, my engineering user is going to get phished, and he's going to have malicious code running on his computer, what happens then? Training is not enough. I cannot stress this enough, really. It is not good enough. We have to have software that itself is phishing resistant. You can buy products that are specifically phishing resistant, and just don't click on anything in your browser. Just don't use your browser anymore. It's dead to me. And for researchers, I really think phishing attacks need more attention. I think there's a lot of room here for novel phishing attacks. I think there's a lot of cool stuff going on. Anti-phishing research is still in really early stages. And the user experience is a critical part of your application security. And it's not all about traditional exploits. And the out-of-scope bug bounty list is a really good place to chain vulnerabilities together. Just look, it's a big list of vulnerabilities they're not going to fix. So I want to leave you with one closing thought, another Gruck quote. Give a man no day and he'll have access for a day, but teach a man to fish and he'll have access for life. The code's available on GitHub, so you can check it out. You can also read about it more on my website. Any questions? Question. So the question was, have I tested it with YubiKey? I don't have a YubiKey, so no, but it should work with YubiKey. YubiKey, one of the nice things about YubiKey is you can't repeat them, but because you're not ever giving LastPass the YubiKey code, you're never using it twice. So I'm using it in your stead. So it should work with YubiKey, although I did not test it. Any other questions? Yes, you.
You said look for phishing-resistant software, but who's going to determine whether it's phishing-resistant or not? I'm sure LastPass would their software.
So the question is, who determines what software is phishing resistant? The buyer has to. You have to then evaluate it yourself. I know this puts a lot of work on buyers, and it's hard to buy software, but you have to look for it, and you have to do your research and find out, is this software phishing resistant? So like the latest version of Office is a little more phishing resistant than 2010, and I think you should take that into account. All right. Am I out of time? Stop? Okay. Well, that's it. Thank you very much.